1.7 deals with linear inequalities. So a linear inequality is an inequality that can be written in the form ax plus b is less than c, where a, b, and c are real numbers and a is not equal to 0. Now just keep in mind, as far as the definition for the linear inequality, the less than sign could be replaced with a greater than, less than or equal to, or greater than or equal to sign. Alright, so for our first example, we want to solve the linear inequality and express the solution in set builder notation. Alright, so the first thing we're going to do is we are going to go ahead and solve for the variable x. Now looking at this problem, I'm going to move everything with the x to the left side, everything that does not contain an x to the right side. So the first thing I'm going to do is I'm going to add 8x to both sides. That gives me x minus 3 is greater than 6. Now I'm going to go ahead and add 3 to both sides, and that gives me x is greater than 9. Now when you're asked to do express the solution in set builder notation, what you do is you open up a braces and then you put whatever your variable is. So in this case it would be x. Then you put a line that goes straight down that is read as such that. So you have x such that, and then you just put your inequality here. X is greater than 9. Close your braces, and that is your solution. Now that is set builder notation. Be very careful, as you'll see in the example down below. Some of the problems will ask for your answer in interval notation, so be very mindful of the notation that the question asks for. Alright, the next problem, we've got fractions. Alright, so what do we do if we don't like fractions? We get rid of them. We multiply by the least common denominator. In this case, that means I'm going to multiply both sides by 10. Right, so I've got 10 being multiplied by 5 over 2x plus 10 times 4 is less than 2/5 times 10. So I'm going to simplify to get rid of my fractions right away. 2 goes into 10 5 times, and 5 goes into 10 2 times. So I'm left with 5 times 5x, which gives me 25x, plus 4 times 10, so plus 40, is less than 2 times 2, so it's less than 4. Right, so I'm going to subtract 40 from both sides so I can isolate my variable. That gives me 25x is less than negative 36. And then I divide both sides by the coefficient in front of my x, and I get x is less than negative 36 over 25. Recall that it wants the solution in set builder notation, so I put braces, x, a straight line that's read as such that x is less than negative 36 over 25. Close my braces, and that is my solution. So the next one, the next set of example questions asks to solve the linear equality once again, but this time you're going to graph the solution set on a number line and express the solution using interval notation. Alright, so just like before, I'll go ahead and rewrite the equation. You've got negative 4x plus 3 is less than or equal to negative 5x minus 2. First thing I'm going to do is move everything with an x to one side. So I'll add 5x to both sides. That gives me x plus 3 is less than or equal to negative 2. I'll subtract 3 from both sides and get x is less than or equal to negative 5. Now I highly recommend, before putting it in interval notation, go ahead and graph it. So if you're saying x is less than or equal to negative 5, that means you are going to have a bracket or closed circle, and you are going in this direction. X is less than negative 5. You could always pick a test point to make sure that you're going in the right direction as far as with your arrows. For example, if I went over here, I drew it over here, 0 is clearly not less than negative 5, so I know it wouldn't go in that direction. Alright, so now looking at the picture, I go from smallest to largest. So that means I'm going from negative infinity, notice parentheses around negative infinity, to negative 5 with a bracket. So that is an interval notation. For the next one, I've got negative 4x minus 5 is greater than negative 5x minus 11. Once again, I'm going to move everything with my variable to one side. So I add 5x to both sides. That gives me x minus 5 is greater than negative 11. I'll add 5 to both sides. And that gives me x is greater than negative 6. So at negative 6, I'm going to have a parentheses or open circle. And I'm saying x is greater than negative 6, so it goes in that direction. So it's going from smallest to largest, negative 6, parentheses, to infinity. Now the next type of problem that we're going to look at with our inequalities is three-part inequality. And once again, you're asked to put your solution in interval notation. Alright, so with a three-part inequality, whatever you do to one side, you have to do to the other two sides. So all three sides have the same actions taken. Right, so if I look, I've got negative 7 is less than or equal to negative 2x plus 3, which is less than negative 5. So I want my x to stay in the middle. So I'm going to subtract 3 so that it is all by itself. That gives me negative 10 is less than or equal to negative 2x, which is less than negative 8. Next thing I'm going to do is divide both sides by negative 2. Now, very important with inequalities, if you multiply or divide by a negative number, you have to flip the inequality. So when I divide this side by negative 2, 10 divided by negative 2, that gives me 5 is greater than or equal to x, which is greater than negative 8 divided by negative 2, which is 4. Alright, so that means that x is greater than 4, so at 4 I'm going to have a parentheses or an open circle, and it is less than or equal to 5, so at 5 I'm going to have a bracket or a closed circle. Written in interval notation, start with your smallest, so that would be 4, comma, 5, and the bracket around the 5. Alright, so we're going to do this next one the same way. So I've got 9 is less than or equal to 2x plus 3, which is less than or equal to 13. I'll subtract 3 from both sides. So that gives me 6 is less than or equal to 2x, which is less than or equal to 10. Divide both sides by 2, or all three sides by 2, sorry. 3 is less than or equal to x, which is less than or equal to 5. So x is greater than or equal to 3, so I've got a bracket at 3. It's going in this direction. And x is less than or equal to 5, so I've got a bracket going there. So my solution here goes from 3 to 5 with a bracket around both. Now the last type of linear inequality that we will talk about in this section are compound inequalities. Now for compound inequalities, it is very important the words that you see in regards to and or, right? So you have to pay very careful attention to that. You want to express the solution using interval notation, or state that there is no solution if that's the case. Alright, so what we're going to do for this, I'm going to color code it to make it hopefully a little bit more clear. First thing I'm going to do is I'm going to solve for this one right here. I've got x minus 3 is less than or equal to 1. So what that means is that x is less than or equal to 4 because I simply just add 3 to both sides. Alright, so I'm going to go ahead and graph that. X is less than or equal to 4. So I'm going to put a bracket here, and it's going in this direction. Right, and this, I'll just write it down here, x is less than or equal to 4. Alright, now for the next one, I've got x minus 3 is greater than negative 4, so I add 3 to both sides, and I get x is greater than negative 1. So x is greater than negative 1 means I've got a parenthesis at that negative 1, and I'm going in this direction. Now here is the tricky part. Here is where the compound inequality comes in and the word and. So I wrote this in two separate colors, or I drew it in two separate colors for a reason. When I see and, it means I need both colors to be represented there. So I'm essentially looking for the overlap of the two graphs. So here I see they overlap at that negative 1 with the parentheses, and it goes all the way until 4 with a bracket. So my solution here is parentheses negative 1 to 4 with a bracket. Now for the next problem, we have the word or between our two linear inequalities. So let's start off the same way that we did the last problem. So I'll start off with this first linear inequality. I'll add 9 to both sides. That'll give me 7x is greater than 14. Divide both sides by 7. And I get x is greater than 2. So at 2, I'm going to have a parentheses. I'm going to go in this direction. And there we go. Now for the next one, I'll subtract 7 from both sides. That gives me negative x is greater than or equal to negative 15. I'll divide by a negative 1, so that gives me x is less than or equal to 15. So pretend that this goes all the way to 15. And I'm saying x is less than or equal to it, so it's going to go in this direction. Now here, I've got the word or with my compound inequality. What that means is it just needs to be touched by any of the linear inequalities. So if I'm looking just at the graphs, that means that there's just any color. It doesn't matter if it overlaps. It does not need to overlap. So in this case, it overlaps on everything. So my solution would be negative infinity to infinity. Because there is no portion on this graph that is not covered by one of the two colors. And because I have the or, I'm just looking for it to touch one of the two colors.